Hello everyone, my name is Gamanji and I'm one of the cloud platform engineers for American Express. I joined American Express around 6 months ago and I'm part of the team that aims to transform the current platform by embracing the cloud native principles and making the best use of the open source tools. As well, quite recently, I've been elected as one of the TOC, the Technical Oversight Committee member for the CNCF. Alongside 10 other champions within the open source community, I'll be responsible to steer and maintain the technical vision for the CNCF landscape. Pretty much we're the community that enables and leverages projects to move throughout the CNCF pipeline. Today, however, I would like to talk about ClusterAPI and more specifically to provide a guide on how to get started to experiment and use this tool. And to do so, I would like to introduce firstly the ecosystem that enabled ClusterAPI to be developed as a tool. Then I'm going to follow this by introducing and describing the ClusterAPI components. And I'm going to finish with giving an example of how ClusterAPI can be used in association with the GitHubs model. Before I move forward, I would like to introduce the ecosystem that allowed ClusterAPI to be developed. Now, if you look 6 years ago, the container orchestrated framework space was very heavily diversified. We had tools such as Docker Swarm, Apache Mesos, CoreOS Fleet, Kubernetes, and all of them provided a viable solution to run containers at scale. However, in the last years, Kubernetes took the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly, for its approach towards declarative configuration and automation. And this has been extremely beneficial for Kubernetes because over time, a community flourished around it. Based on the CNCF survey in 2019, more than 58% of the surveyed companies are using Kubernetes in production. The other 42% are actually prototyping Kubernetes as a viable solution to move forward. When we transition towards the development community, more than 2,000 engineers are actively collaborating towards feature build-out and bug fixing. And when we look into the end-user community, more than 23,000 attendees were registered at the KubeCons around the world. Now there's going to be KubeCon in Europe, China, and North America. And this has been extremely beneficial for Kubernetes because over time, multiple tools were built around it to extend its functionalities. And this created what today we know as the cloud native landscape, which resides under the CNCF umbrella. Now, if you look into all of these tooling, some of them are going to provision similar capabilities, such as service mesh or networking, runtime. And another category we can identify is the cluster provisioning or bootstrapping. Currently, there are more than 100 distributions to actually allow the bootstrap of a cluster. And ClusterAPI is one of those tools as well. If you look into the ecosystem, as mentioned, there are a plethora of tools provisioning this capability. Some of the most widely tools are such as kubeadm, kubespray, kops, Tectonic, and many more. However, if you look into every single tool, it's going to be difficult for us to find a common denominator. What it actually means is that every single tool is going to integrate with a very specific subset of cloud providers. And this in itself imposes quite a few challenges. Supposedly, as an end user, what happens if you'd like to migrate your infrastructure to a different cloud provider? Even if you use the same bootstrap tool, there's going to be very little reusable components. Usually the end result is going to be rewriting your infrastructure as code from scratch. Another challenge is imposed if you'd like to migrate to a different tool altogether. For example, Tectonic, which I introduced earlier, is no longer under active development and it is to be merged with OpenShift Container Platform. That means that moving forward, one solution is to fork the project and maintain it in-house, or you'll have to choose a different tool, which means that you'll have to rewrite your infrastructure as code from scratch again. Then another challenge is presented by areas such as China and sometimes Russia, because it's quite challenging to deploy your infrastructure to those areas. And this is because in China, for example, there is an entire subset of tooling already provisioned for the cluster bootstrapping. Usually we lose these lift and shift capabilities, and we have to create a snowflake infrastructure in these regions. However, ClusterAPI intercepts all of these challenges and provisions a set of declarative APIs that will allow the cluster creation, configuration, and management. And more importantly, it will integrate with different cloud providers. When we're talking about Cluster API, we refer to SIG Cluster Lifecycle, which had its first initial release in April 2018. Since then, they had 2 more releases, and they currently present a V1 alpha-free API endpoint. Now, I was mentioning the Cluster API integrates with multiple cloud providers, and currently there are 14 of them, from which we have the support for some of the major cloud providers such as AWS or GCP. There is an initiative to integrate with bare metal providers as well, such as Metal-free or Packet. But more importantly, we're going to have the support for Chinese cloud providers, such as Baidu Cloud, Alibaba Cloud, and Tracent. And this means that the Cluster API really enables and empowers the end users to create a cluster in China with the same ease they would create a cluster in Europe or in the US. Now, let's look a bit in more details how Cluster API works. Supposedly, we would like to create a subset of multiple clusters in different regions, different cloud providers. The first thing we're going to need to provision is going to be the management cluster. For testing purposes, it is recommended to use Kind, and Kind is just a Dockerized version of Kubernetes. If you'd like to use Cluster API in production, if you're one of the early adopters, it is recommended to use a fully fledged Kubernetes cluster. And this is because it comes with a more sophisticated failover mechanism. Once we have our management cluster, we require our dependencies, known as the controller managers. And to have a fully working version of Cluster API, we'll require 3 sets of controllers. One for Cluster API CRDs, one for the Bootstrap provider, and the last one for the infrastructure provider. Now, Cluster API introduces 5 new custom resource definitions, and we'll require a controller for every single one to make sure that we can create, delete, or reconcile any changes we have to these resources. The second component with the second controller is going to be the Bootstrap provider, and this is going to be the component which will translate the YAML configuration into Cloud Init script, and it will make sure to attach an instance from any cloud provider to the cluster as a node. Currently, this capability is provisioned by kubeadm and Talus. And the last set of controllers we'll require are going to be the infrastructure providers. And this is the particle which actually interacts with the APIs directly and provisions the infrastructure, such as instances, subnets, IAM roles, VPC subnets, and many more. It is worth to mention that if you'd like to create a cluster in multiple cloud providers, you'll require a controller for every single cloud provider as well. And once we have our dependencies, we'll be able to provision our target clusters. And these are going to be the clusters we will deliver to our engineers to put their application on. And these are going to be the clusters the consumers or our users are going to connect to interact with our application. Now, as mentioned previously, Cluster API introduces 5 new resources: cluster, control plane, machine, machine set, and machine deployment. The cluster resource is going to be taking care of mostly of the networking components for a cluster. We'll be able to specify settings such as the CIDR for our services and pods, as well any DNS suffix if you have it. The control plane is a new resource which has been introduced in the last release, so the third release. And it provides a declarative way to manage your control plane or the set of masters. Machine configuration is going to be very similar to Node. We'll be able to specify the version of Kubernetes we'd like to run. However, we'll be able to attach information such as the instance type, the region you'd like to run this machine in, if you'd like to attach any SSH keys, and so forth. Machine set is going to be very similar to replica set. It will make sure that we have an amount of machine resources up and running at all time. And machine deployment is very similar to deployment. It actually comes with a very powerful rolling out strategy, making sure that we can reconcile any changes to our machines. It is worth to mention that the machine resource is immutable. Now, if you have new configuration, the instances of the resources with the old configuration are going to be taken down, and the new instance with the new configuration is going to be brought up. There is no patching, there is only immutability. To actually showcase the simplicity to configure your cluster using Cluster API, I would like to make a comparison between the current way and introducing a tool such as kubespray. Now, kubespray is a tool that will allow the provisioning of a cluster by using Ansible as infrastructure as code. In this view, we have a trimmed output of some of the roles an engineer would need to be aware when creating, debugging, troubleshooting, deleting a cluster. ClusterAPI completely rethinks this process, and it reduces the cluster creation to a couple of manifests. If you'd like to create a cluster in AWS, this is going to be the manifest you're going to be requiring. Here we have a cluster resource in V1 Alpha Free endpoint. And in the spec section, we just choose a /16 subnet for our pods. As well, as mentioned with the new version, we're going to have a control plane reference. You can see that towards the end of the manifest. However, I would like to draw your attention towards the infrastructure reference, because this is the configuration which will interact with our cloud provider. In this particular case, we have an AWS cluster created in V1 Alpha Free endpoint. Now, what's actually going to happen underneath, it will invoke the parameters which are specific for this cloud provider. As such, we say that we would like to create our cluster in region EU Central 1, and we'd like to attach an SSH key name with the name default to our instances. Now, if you'd like to create this cluster in GCP, these are going to be the only changes required. As you can see, the only thing we changed in our infrastructure reference is the kind of our cluster. Is going to be GCP cluster now. And this will invoke the values which are very specific to GCP. As such, the region naming is quite different. We're going to have Europe West Free. We have the concept of a project, which is quite specific to GCP as well. And we associate our cluster with CAPI. As well, we'll be able to attach a network. And in this case, we just provision its name. But more importantly, we can see from this example that we can reuse our manifests with very little changes in between them. So far, we just created our cluster resource. To have a fully working target cluster, we'll require to actually have our control plane, which is already associated with our cluster. So with the control plane, we're going to have all our masters already managed. And of course, we require our data plane, and this can be represented by a machine deployment, which is just going to take care of a collection of machines we will define. And the last concept I would like to introduce is how can we use ClusterAPI with the GitHubs model. Now, the most powerful concept ClusterAPI actually introduces is that we can think about our clusters as resource. We can fully translate that in YAML configuration. If we have YAML configuration, that means that we'll be able to have it stored in Git. So we're going to have a versioned, a control around the versions and the history of these resources. And more importantly, we'll be able to introduce a layer of templating. And usually this is provisioned by configuration managers such as Helm and Customize. And once we have these two components, such as Git and configuration managers, by default, we'll be able to make use of a tool, a GitHubs tool, currently provisioned by Argo CD or Weave, actually Flux, provisioned by Weaveworks. Now, the GitHubs model uses the Git repositories to describe the desired state of an application. And this is exactly where we actually reach, or the climates we reach with ClusterAPI, because we can fully automate the cluster provisioning with just one click. And this is precisely what I would like to demonstrate today. So let me just share my screen very quickly. Cool. So at the moment, I already have a cluster provisioned with ClusterAPI, and it currently has 5 nodes, 3 masters and 3 workers. And in this demo today, I would like to showcase how can we scale, for example, the amount of our work nodes by using the GitHubs model. Let me explain what we actually have in this view. Currently, in the bottom part, we actually have all the machine resources for our cluster. As you can see, 3 of them, 3 of them are our control plane, and 2 of them are our data plane or machine deployments. Now, when I'm connecting to my cluster, and currently I am connecting by using a kubeconfig file, which is just stored as a secret, I'll be able to see that again, I have a cluster with 3 masters and 2 nodes in version 117.3. But more importantly, what's worth to mention is that this particular cluster was provisioned by using Argo CD. So currently I have an Argo CD model, and if I just take the app details, I'll be able to see that I'm provisioning a repository URL where I have all my manifests stored. And of course, I can parameterize that by using a values file. And if I just look into that particular repository, so this is the ClusterAPI GitHubs repository. In the templates, I'll be able to have all my custom resource definitions. I'm going to have my cluster resource, which we actually went through previously in the slides. So again, I'm just choosing a CIDR for my pods. I'm having a reference to an AWS clusters and so forth. But more importantly, as you might notice, this is already a Helm chart, and I have already templating enabled on it. As such, I think if I go to deployment nodes, I think that's going to be a better example. What I actually have, for example, you can see that I can template the version of Kubernetes I have, and this is a very specific way for Helm to actually consume these values. Or, for example, I can template the amount of replicas or the amount of nodes I'm going to have in my cluster. And just to showcase the values file, currently it's very straightforward. It's just kind of an example to showcase this mechanism. But what I'm templating here, as mentioned, is the kube version, the amount of masters or control plane, and the amount of workers. Now, if you look into our Argo CD view, we'll be able to see that, for example, we have already 2 machines, which are this one, and actually 3 of them. This one, and this one, which are going to be the control plane, the masters. But more importantly, we're going to have a machine deployment, which defines our data plane, with a machine set associated, and 2 machines, very similar to a deployment within Kubernetes. And currently, if I go to my values file, I would like to change the amount of replicas, for example, to 5. I'm just going to commit that with a very simple commit message. I'm just going to have it as a demo, and I'm just going to push my changes. So now, when I'm actually going back to my Argo CD view, I'm going to trigger a lookup. So it's actually going to look into the repository to see that we have a new value for our worker nodes amount. And once it's tried to actually synchronize, hopefully soon, we'll be able to see that the amount of replicas for the machines will increase. I think I need to sync it because I set it to manual as well. Cool. Yes, as you can see, we have new machines actually being provisioned. If we go back to our cluster, we see that 3 new machines are actually to be provisioned. And the most important thing, if you look into AWS as well, console, we'll be able to see that we have 3 new machines actually being initialized. And this is a very powerful concept because we really can automate the entire process of creating a cluster. And we really can treat our clusters as cattle rather than pets. We can recreate it with minimal ease. It actually is just at the end of a click. So 1 click, we have a cluster up and running. And this pretty much concludes my demo. I'm just going to return to the slides. Now, before I finish, I would like to leave you with a few takeaways about ClusterAPI. ClusterAPI has been so efficient and so successful in such a short amount of time because it uses the building blocks principles. It does not concern itself to integrate with Kubernetes and provisions its capabilities that way. It actually builds on top of the available primitives and makes the best use of custom resource definitions. Another important feature about ClusterAPI is the fact that it's cloud agnostic. It truly provides this one interface which will allow us to integrate with different cloud providers, but more importantly, to use and reuse our manifest all the way through. And the last thing I would like to mention about ClusterAPI is currently under extreme active development. If you have a use case for ClusterAPI, please give it a try and feedback to the community. Now is the perfect time to customize ClusterAPI to your use case. If you'd like to know or to find more technical details about ClusterAPI, I did collaborate with one of the maintainers of ClusterAPI to provide actually a CNCF webinar. So if you'd like to understand ClusterAPI from a maintainer point of view, please visit or watch the webinar over there. As well, I have written an article with more details of how can you actually start playing with ClusterAPI and experiment with that, that's going to be available on Medium. And if you have any questions in regards to today's talk, I'm always going to be available on social media such as Twitter or LinkedIn. Enjoy the rest of the conference. Thank you. Hello, everyone. I think I'm on here. Cool. There are plenty of questions actually coming in later on, especially in the last minute. So I will try to tackle as much as I can through this live Q&A. Otherwise, I'm going to be available in the KubeCon operations channel in the Cloud Native Slack workspace. So a couple of questions which actually stood out were the question about when ClusterAPI is going to be beta or GA. Now, there are some currently ClusterAPI is in V1 Alpha 3, and in the new release, they're actually trying to move to a more stable version. It's actually stable, it's used in production, but to actually gain that status, I think it's something which is going to happen in the next release or the next couple of releases. So it's definitely on their radar. Another question, which actually was an underlying thread here. So the question is related to things. For example, we already have cloud providers and a native way for them to provision Kubernetes clusters, such as GKE, AKS, EKS. What is the benefit of ClusterAPI instead of standard infrastructure as code framework? Now, this is pretty much a more kind of complex answer. ClusterAPI tackles a few challenges. If you don't want to be locked into a specific vendor, then you might consider ClusterAPI as a solution for you. Because if you're going to use, for example, GKE or EKS, if you'd like to, for example, for cost reasons, you'd like to transition to a different public cloud, that's going to be a bit more difficult. You'll have to recreate your clusters from scratch, infrastructure as code as well. And as well, you will not be able to migrate your, for example, GKE Terraform to an, EKS. So it's going to be quite a different approaches to do that. With ClusterAPI, we actually can have this consistent amount of manifests that we'll be able to use throughout. And this is pretty much one of its kind of highlight of why it's such an important tool, because you have one interface to plug in into different cloud providers, and you can reuse the manifests as well. So infrastructure as code, it's something it is just a fundamental, and you can build on top of it. Some of the other questions. One of the good questions I think to answer is how ClusterAPI works with bare metal on-prem clusters. So currently, if you're thinking about provisioning your cluster on a complete bare metal machine, that's not something fully supported. However, that's supported through providers such as Packet or there's Tinker as well. So you actually have to kind of use a provider. But if you just take a VM and if you want to use ClusterAPI on top of it, it's going to be a bit more difficult because there's no API to actually integrate and automate the provisioning of those machines. Cool. Another question, which was actually quite interesting, is since we have, especially related to the demo, since we actually have our declarative approach for the amount of replicas we have in a cluster, so with the GitHubs model, we'd be able to set amount of workers and amount of masters. How does that interact with cluster autoscaler, and which actually is going to determine the machine number? Now, this is something which is still worked on because currently, with the ClusterAPI context, we do not have that automated cluster autoscaler. So for example, if you want to use that with AWS, you have to integrate with AWS specifically and actually provide all the credentials for you to identify how many replicas of your machines you require. Currently, this is, I know this is like a feature they're working on, but currently at the moment, it's something which is done manually to actually set your amount of machines. So again, it's still working. So if you have this kind of feedback, it's quite valuable to provide it to the maintainers so they can actually create an efficient backlog of the features that the community requires. Oh, another question, which actually I think hopped on quite a lot in the past as well. Are you able to import an existing cluster into ClusterAPI approach? Probably no, because there's so many nuances of how you created that initial cluster. Did you create it manually? Did you create it with a specific cloud provider? The versioning, all of this is difficult to predetermine with ClusterAPI. The easiest way is to actually create it from scratch with ClusterAPI. So there's not, because there are like so many nuances, because we're not talking about how can you migrate existing AWS clusters. We're talking about any kind of clusters. And that implies a lot of kind of tweaking, a lot of detailed configuration for the cluster to be up and running. And from that reason, it's quite difficult to determine one standard way to transition those clusters and manage them with ClusterAPI, because ClusterAPI is not just provisioning. In the future, they're actually aiming to, for example, to upgrade the clusters. And that's why they introduced the control plane resource, which is quite new. It actually appeared with the last resource. And with that, you'll be able to actually upgrade your control plane, so upgrading your masters one by one, the same. How reliable is to use ClusterAPI in production? So currently, ClusterAPI is mainly maintained by VMware. Talking to the maintainers, they already have teams which are using those ClusterAPI to provision production clusters. So there are use cases, but definitely I encourage people, if you actually have a use case, try it and do feedback, because we really require that insightful information of how different teams in different contexts are using ClusterAPI. Right. There are plenty of questions. There are like so many questions. I'm trying to go through them, choosing some of the best ones to answer at the moment. How does management cluster relate to the target clusters? So this is like a quite new concept introduced by ClusterAPI, because you have this inception model. You require a small cluster, just like this incipient cluster, to create clusters in different cloud providers, whatever you want. So the target clusters are going to be the clusters you're going to be provisioned to your developers. They are the clusters who's going to hold your applications. These are like the final thing, the result. With the management cluster, that's why you can, at least in my example, I use just a kind cluster, which is very easy to provision. You just have kind create cluster. You have it already in your local machine. You just need that because it works with CRDs. It works with Kubernetes manifests. You require a context in Kubernetes to actually deploy all of these resources. There's why management cluster is actually important. So this is the incipient cluster, and from there you'll be able to create more and more. Yeah. Let's have a look. What about the support for Rancher and OpenShift? Is that something on the roadmap? In terms of the integrated cloud providers, definitely there is, if I'm not mistaken, there is already a integration with Red Hat. I'm not entirely sure if it's going to be OpenShift, because OpenShift is a very similar offering, such as GKE is a managed cluster, it's a managed service by Red Hat. However, I'm not sure about Rancher. There might be some initiatives there, but definitely there is, as long as there is an API endpoint to create your infrastructure, you'll be able to integrate with ClusterAPI. So I don't see any barriers there. Some of the listeners here, they actually could initiate that particular collaboration. Why not? It's all about the community, right? Cool. There are plenty of questions about their bare metal. Again, mentioning here, it's if you're actually using a provider which works with bare metal, then you'll be able to do so. On a simple machine, unfortunately, that's not the case yet. I think there was a question in regards to, if using ClusterAPI, does it mean you cannot use KubeSpray anymore or tools like KubeSpray. That's definitely not the case. I think these tools, and this is why it's all about this open collaboration and open source, because you have multiple solutions for the same problem. So with ClusterAPI, you'll be able, again, if you would like to provision multiple clusters in different infrastructure providers, having reusable manifest, that's going to be the case. If you'd like to use KubeSpray, for example, to have Ansible as infrastructure as code, and you can integrate with AWS, or you can do this on bare metal, that again is right. It's more about like the different problems they actually solve. One is just a simple, with KubeSpray as well, we integrate with only a couple of cloud providers, while ClusterAPI is more extensive. So again, it really depends what you're trying to solve. It really depends what actually is the end result you want to get out of these tools, and how do you want to describe and manage your infrastructure as code. And I've actually got a notification that I've got 30 seconds left. So I think this is going to be my last question to be answered. But again, I'm going to be available on social media. If you have more questions, please let me know. Please do read the article on Medium, watch the webinar, and I'm going to be available on Slack as mentioned before. So thank you very much for all of your questions.